So Microsoft, for example, they have really questioned these new recommendations and more or less pulled out from participating in the work at ASHRAE. So they want to demonstrate that servers are very robust pieces of equipment. So they, behind their building here, they put up this tent, they put in 5 HP servers, and they let them run for a year, and it was like raining, and leaves were flying around, and no temperature control at all, no humidity control, there was no control. And it turned out that they just continued to run there, there was no problems. They were a little bit outside that big range we saw before, but still, they survived. But this was just 1 year, so you might get effects over several years and they break down prematurely, but we don't know that. But I think what they have demonstrated is that we don't need this precision cooling in data centers. But we should be allowed to open up and by that save more energy.
Where'd you get the title for that slide? Microsoft Data Center in a tent.
So what does this have to do with energy efficiency? Because that's what we're going to look. That's why you came here today, to learn about energy efficient data centers. Well, this has a lot to do with energy efficient data centers. Today, many data centers operate with a supply temperature of 55 to 60 degrees Fahrenheit. And if these ranges you are supposed to operate within are wider, or you can operate at a higher temperature, you can raise the supply temperature, and you will then improve chiller efficiency. Raising the supply temperature also increase economizing utilization. And ADC's data center, they have, or they will have, an ASHRAE economizer, and that will really be impacted by this wider range. You're going to reduce energy for humidification and dehumidification. That can be quite substantial in some data centers. Now, just keep in mind that if you're raising your supply temperature too much, you might run into a situation where the servers actually ramp up the internal fans because the intake temperature to that server is a little bit on the high end. And most servers today have two-step fans or variable speed fans. So they might gear up, and they will then consequently draw more electric power. So that's a drawback. Next, please. Determining compliance, and this is important because now we have range, the recommended range and allowable ranges for temperature. How can an end user or a consultant demonstrate that this particular design will operate within the recommended and allowable ranges? Well, then there is this nifty thing called the rack cooling index. And it really, we have two parts of it, RCI high and RCI low, and as it sounds like, high is the high range and low is the low range. So if you have RCI high, 100% means that you don't have any over temperatures. All temperatures are below that maximum recommended, right? If this is the band, we don't have anything up here. That means 100% are RCI high. 100% of RCI low means that we don't have any temperatures below the minimum recommended. And if both, consequently, are at 100%, we have absolute compliance. That's the ideal situation. All temperatures will be in that band, the recommended band that we talked about. And that's what we would like to see. So they provide a measure of thermal compliance at the high end and at the low end of the intake temperature range. Remember, all these temperature ranges are for the intake temperature to the servers, nothing else. The only thing that counts in a data center is the temperature going into the server, because that's the temperature that's going to cool the equipment. If it's hot somewhere else in the space, like on the rear equipment, doesn't matter, right? It's not used for cooling electronic equipment. All right, so what is a poor value then? 100% is ideal. Usually when you're below 90%, it becomes a little bit problematic, probably. Just a few more slides here. So when you're going to show compliance with the ASHRAE thermal guideline, there are two metrics there, RCI high and RCI low. And if you have a really good installation, that's going to be, both of them should be at 100%. Again, you know, everybody think about it. 100% is like, can it be better than 100%? No, that's like 100% is the best, right? Same thing here. So this rack cooling index, it is included in the ASHRAE thermal guideline now. It's also used in something that DOE is working on. It's called DC Pro Software Tool Suite. It's a whole suite of software tools that I'm one of the consultants working on that project. RUMS is another one. Taylor Engineering in the Bay Area, and also HP EYP. In that software tool suite, RCI is used to show compliance with the recommended ranges. It's also taught in the DOE Certified Energy Practitioner Program. What the heck is this now? This is another big program by DOE that I happen to lead. This is developed or to train energy assessors for data centers. We don't have a standard today for the quality of people going out there and assess data centers. That's what this is all about. And RCI has a role there too to play. If you want to understand, need more information on this, you can talk to me, or DOE, LBNL, and myself. We will present this at ASHRAE now in Louisville in a couple of weeks. And data center dynamics in San Francisco. We will also present the same presentation there. So if you're interested, you can learn more there. RCI is going to be benchmarked at LBNL. It starts to migrate into CFRT tools and data center monitoring tools to show compliance. Sorry, this goes really fast, but 15 minutes is very short. All right, this is, I had the opportunity to work with RUMS engineers and ADC to model this with CFD models. And this is a model of a part of the data center. And back here is the fan wall pushing in the air in the aisles here. And RUMS is going to talk about this, so I'm not going to steal his show. I just want to show here that the supply temperature is 72 degrees. That's fairly high. And if you look at this, there is a plane here with blue colors. And as you can see, it's pretty blue, right? It's no red colors. It means that the thermal environment is really good. And here are the enclosed hot aisles then. And then here are the ducting going up to the return. All right, so here we have, I'm going to show you the results of RCI high and RCI low for that previous slide. We did a number of simulations of this data center. It kind of evolved during several months. Remember, RCI high is the indicator of how well you're controlling the upper limit of the recommended range, and RCI low is an indication how you're controlling the lower range. So next, please. So if you can go back to another one. So,
no.
So my point here is that, as you see here, this dial goes from 0 to 100%. And what is the best now? 100%, right? The amazing thing with this data center is that the calculations indicating that both RCI high and RCI low is at 100%. That is a little unusual, actually. That's a very good result. So the thermal environment is fantastic. And I'm sure that RUMS is going to talk about the energy efficiency measures, that they're very good. So we have a unique situation here that we're providing an extremely good thermal environment. And we're also saving a lot of energy. So there is no contradiction between saving energy and creating a good, reliable environment. Now, did you see on the other slide that the supply temperature in these calculations was 72 degrees? That was according to the old guideline in ASHRAE. So I would think that RUMS might be thinking about adopting this new recommendation instead and be able to jack up that supply temperature to at least 75 degrees. And in that situation, I have a feeling that you don't need to turn on those chillers that often. So I hope that was a nice transition into Peter's talk.
But we got a good question.
Questions?
What was the basis for the maximum temperature recommendation in your new standard?